So now let's move on to the comparison of the architecture of the virtual machines and the Docker. So we'll be at first starting with the virtual machines, and as you can see, we'll be starting the description through the infrastructure. So basically that's going to be your laptop or your servers where you host your virtual machine, and in order to run that on top of the infrastructure, you'll be needing a host operating system where you can run your infrastructure. So that might be Linux, Unix, Macintosh, or your Windows OS. And to run the virtual machine, you need services like Hyper-V or VMware's. And after implementing that for a single virtual machine, you will be needing a single guest operating system. So you might have already tried it out. So having a virtual disk or an ISO file, mounting it and creating a virtual disk. So for a single virtual machine, you will be needing a single guest operating system to run that virtual machine. And after you get on through that, you can use the services like the binaries and the libraries to host or run the applications. So now we move on to the architecture of the Docker. So the initial steps is going to be similar. We have the infrastructure there, and to run the infrastructure, we need a host operating system. But instead of the services like Hyper-V, we'll be having a Docker engine right there. So the difference, as you can see, in the figure itself is the guest operating system. While using the Docker engine, we won't be needing the guest operating system. So by using Docker engine, we can directly use the binaries and libraries to host and run the applications. So as we have already been through the advantages of Docker, I would like to focus on the portability and the removal of platform dependencies quite much, as we'll be dealing with that a bit later. So now we move on in depth about the operation and functionality of Docker. To start with that, we'll be going through what a Docker image is. So Docker image, it's basically a read-only template that contains a set of instructions which we can use to create a container that runs on the Docker platform. So here we have an illustrative image of Docker images and container. So it uses the concept of the logo of Docker. So there, the blue well, it signifies the ship which holds the containers, and also is the resemblance of the Docker engine. So as you can see, there are multiple containers that's been holded by this ship, and that container kind of might be your web server, that's a Apache server or an Nginx server. That might be your backend server, your PHP or your PHP MyAdmin. So it kind of like also be your database, which you can use it MongoDB, MySQL, or MariaDB. Or Postgres, it can also be a container of Python. So you have multiple possibilities to explore around. So I've already given you the illustrative overview of what a Docker engine is, and so we go on in depth about that. So what is a Docker engine? So it is an open platform, and it is used to develop and ship and run applications. So basically these 3 points is kind of like a motto of Docker. So Docker engine is an open platform that is used for developing, shipping, and running application. It also enables you to separate application from your infrastructure, and which promises you for a quicker delivery. So what are the components of Docker engine? We start with that. Okay, at first there comes the server, which is the Docker daemon, which can manage the images and the containers of Docker. So then it comes up with the REST API, which is responsible for the communication between the server and the client. And finally, there comes the client, which is used for accessing the Docker commands in your CLI, where you have the access of Docker. So now let me give you a simple walkthrough. It's quite like an illustrative flowchart about telling you the process of how the pulling of the Docker images, creating of the container, and finally pushing of the Docker image to the Docker Hub is quite done. So let's get on with that. So we'll be doing with the push and pull of Docker images. So here you can see there is the Docker Hub, and it is the collection of the images. So you might you can also say it as the library of the collection of images. At first you pull it to your local machine, and on your local directory you have the images. So you then run it. So basically I've already told you that the Docker image is a set of instructions to create a container. While we run the image, it creates a container. So let's say we have the container with the config files and a Postgres SQL and a start script. So we use the services of that container, and you make certain changes to that container, and the changed container, your custom container, can also be created with a custom image, and then we create with that custom image, we can also push it to the Docker Hub. So this is a basic scenario where we can pull a Docker Hub image from the we can pull a Docker image from the Docker Hub, and then use the services, make changes, and create a custom image, and then we can also push it to Docker Hub. So now let's move on in depth about what a Docker container is. So Docker container, it's a lightweight, standalone, and executable package of software, which includes everything you need to run an application. So it might be a block of code, it might be runtime, it might be system tools, it might be a monitoring tool, it might be a database, it might be anything. So the concept that is required to create these containers and communicate between them is also known to be containerization. So we move on to that, what a Docker containerization is. So it's a open source software development platform which helps you to package application in containers. So after you package those applications in the containers, it is portable to any operating system. So as I've already focused you before about the advantage of Docker, which removes the platform dependencies. So here you have it. So now we move on in discussing about how multiple containers running in your machine communicates with each other. So here we have Docker Hub, which is the collection of the Docker images. You can pull multiple images to your local machine or your infrastructure, and then you run it to create multiple containers. So the multiple containers can also communicate among themselves by the use of opening the ports, which helps you to communicate the services between those multiple containers. So after establishing the communication, you can then exchange the information and exchange the services. So like this, we can hold the use of multiple containers and exchange the services and data and information among them. Thank you for watching the episode 1 of Docker series, and stay tuned for the episode 2 of Docker series. In that second episode, we will be discussing about the Docker installation process and the Docker Hub registration process. We'll also be creating a scenario where we will be pulling a Nginx image, and then we run it in a container in a specified port, and we see that output in our web browser. Thank you.